Okay, 6.1, linear inequalities. Let's first start by discussing this inequality sign right here, and I'm putting it underlined on purpose just to bring your attention to it. That inequality sign acts like an equal sign, algebraically speaking, but not when you graph it out. So if you just think of that inequality sign, whether it is, less than, greater than, less than or equal to, greater than or equal to, whatever, if it really does act like an equal sign, and if you think about it as equal sign, you could easily solve this. So using that idea, I want to get m by itself because this really doesn't make any sense to me unless I get the variable m by itself, where I isolate the variable. In this case, I add 5 to each side, just like if it was an equal sign, 5 to each side, and it gives me m is still greater than or equal to 8. So, and notice how I read that. I read this inequality from the variable side to the number side. I read it kind of backwards if you look at it in the Western way, and that m is greater than or equal to 8. You could have also read it as that 8 is less than or equal to m, but it makes more sense to me if you always read it from the variable side. If I could rewrite this, I could also say this, that m is greater than or equal to 8. So notice that which also means 8 is less than or equal to m. These two mean exactly the same. It's just writing it in two different directions. So let's graph this inequality. I'm going to change my color here so we know we're talking about this, and that we have the number 8 here, and I have the 0 over here, and there's a 8, 7, 6, 5, 4, 3, 2, 1. And I want to know that 8m is greater than or equal to 8. So if it's equal to, I make a circle, I fill in my circle, and it means any number greater than 8. Okay, including 8. Let me look at the next line over here. I'll do this one in purple, where it says, I'm going to read it from the x side, x is less than or equal to negative 2. Let me graph that. Here's my 0. Here's 1, negative 1, negative 2. And x is less than, here's negative 2. Let me put a circle around it. Let me fill in the circle so that we know it includes negative 2. And x is less than negative 2, so it goes in the negative direction that way. And I put an arrow there. And you know what? I forgot to put an arrow on the other one on top to tell me that it's on the other one. And let's do this next one right here, where x is less than 5. So let's draw the number 5 here, number line. Here's 1, 2, 3, 4, 5. And it's less than 5, so I'm going to put a big circle around here. This means it doesn't include 5, and if it's less than 5, the arrow goes in the negative direction. That means the answer could be 4, 3, 2, 1, 0, negative 1, all the way to infinity in the negative direction. Okay, the only tricky part here is when you involve multiplying or dividing across this inequality sign, which I'm putting in dotted lines. When you multiply across this inequality sign, it's a little tricky. So let's just do this first one. I want to isolate the variable x. Negative 2 divided on this side, divided by negative 2 on this side, it gives me x is still less than 3. So, if we do, that's the answer for that one. The issue comes when you are trying to divide by a negative number. So on this side, I have to isolate the variable x. I divide by a negative 2. And when I divide by the negative 2 across this line, is where the inequality is at, I have to switch the direction of the inequality. Only when I divide or multiply across that by a negative number. Divided by negative 2, x is equal to negative 3. And in this case, the inequality, the direction of the inequality is changed. Why that happens? I can't explain it. All I can tell you is that's the rule. If you memorize it, you'll be okay. So, this is the number one mistake that people do. They don't memorize this algebra rule of switching the direction of the inequality
when they divide or multiply across that inequality.